Hello, everybody. Thank you for joining us today for Space Venture's second closing live stream. Where are you guys joining us from? My name is Casey Caballero. I'm from Brownsville, Texas, and I'll be your host for today. I'm operations analyst in Space Ventures, and I work with issuers that want to raise money to build their campaign. Today, we're going to hear about one of the first companies that we had in our platform, and their team is incredible, and you'll get a chance to meet them. So make sure to ask questions. So let's do a little bit of housekeeping before we move forward. You are going to have to be logged into your YouTube channel to make comments, and also make sure to log in into your Space Ventures account. Hi, Melina from Houston. Where's everybody else joining us from today? So once you log in, it's important that you're able to interact with us in the chat because we're gonna have a trivia section coming up, and you're gonna wanna participate on that. I promise. So let's talk a little bit about Exo-Space, the reason we're here. So the Exo-Space team started their company in 2020 in the middle of the pandemic, and yet they've done so much. So let's bring on Jeremy Allen, CEO and founder of Exo-Space, along with Marcel, to talk a little bit about their founding story and how they met and why they decided to start a company together.
Thanks, Casey. Hi, everyone. Thanks for joining us on this live stream. I'm Jeremy, the co-founder and CEO of Exo-Space, and we also have Marcel, who is a co-founder and lead mechanical engineer. So we thought to start out this live stream, we would sort of take a step back and reflect on the last 2 years at Exo-Space. We just wanted to sort of have a conversation, an open conversation. So Marcel, I'll start. Why us? Why did it make sense for us to start a space company?
Yeah, for sure. So yeah, Jeremy and I, we both met at USC in grad school. We actually started working at the Space Engineering Research Center. Jeremy was the software engineer. I was the mechanical engineer, and we quickly found out that we worked well together. We didn't know each other while working in the same room, so that was a plus. And then, Jerry, I remember you expressing your interest in starting a company, and I always knew I wanted to start one. So we started talking. That's sort of how the seed was planted. But then we sort of went our separate ways. I got a job at Disney working as an Imagineer. Jeremy got a job at JPL working for NASA. But we actually connected and ended up agreeing to meet every Sunday for a full day, just block off the day and try and come up with startup ideas in the space industry. We went from CubeSats to assembling devices in space, and we ended up landing on edge computing.
Yeah, and really quick, I do remember these Sunday meetings. We were kind of talking about them before. One thing I remember was, how committed all of us were to making them. We were still working our full-time jobs, but we would commit an entire Sunday to working on new projects. And I think it was like the second time we planned to meet, I had already planned a camping trip, and I was in Sequoia, which was 5 hours away. And I was like, I have to be back on Sunday morning by 9 a.m. So I woke up at 4 a.m. from the campsite, drove straight to my apartment, which is where we were meeting. And yeah, so that's how committed I feel like we all were for an entire year until we landed on something.
Yeah, it was a while that we were doing that for. Looking back, I'm surprised, but yeah, and then once we got our idea, we started pitching it around. So those first pitch events were definitely interesting.
Yeah, those first pitch events, I feel like I felt out of place. I think we probably both did, mainly because it was kind of hard to just find the right events to pitch at. The first event we went to, it was like a speed dating event with investors, and so we're two guys talking about space and space computing and that kind of stuff, and pretty much no one got it. I think we could have improved our pitch, but also it just felt like the wrong place to be. And then I also remember another event. It was with AILA, so it was like a AI focused event, and we spent all night preparing for that event. I think we built some circuit boards with some LEDs. We were up till midnight on a work night, and then we went there the next day, and we had this. We were given this tiny table in the corner of the event, and 2 people passed our booth the whole time, but through those conversations, we continue to go out and try and meet new people and investors and other people who might be interested. And actually the really exciting thing was Space Ventures, their team, Aaron and Brant, were the first people we spoke with, and they were the first outside people, outside of Exo-Space, who really understood our idea right away. It was refreshing to be able to pitch them, and they understood exactly what we were doing, like they were part of our company. So that was an exciting turning point for us, I think. The next big turning point was our first contract. So yeah, Marcel, do you remember how that went down?
Yeah, I mean, it was a bit of a shaky start for us in 2020. Pandemic hit, I actually just was let go from Disney because of it, and then had to go to Canada for like 6 months. So that was a little rough. And then, but the director of the Space Engineering Research Center where we worked actually connected us with another startup, and that's where we got our first contract. And it was sort of the lifeline for Exo-Space. But since I wasn't in the country, we actually had to hire another engineer to work on the contract. So we're posting on Indeed and ZipRecruiter and just reading through a bunch of resumes. But I think Jeremy was reading through a lot of them.
Yeah, I was reading through a lot. One thing that I remembered actually before I go into that part was when you were back in Canada for those 6 months. I remembered we had a couple conversations with some attorneys, for various product related stuff. And one of them, Marcel had to quarantine when he was back home, and he was in his parents' basement, and it was, the winter in Canada. So he had a blanket over his shoulders, and it was in a dark basement. And one of the attorneys I remember was like, "Marcel, are you okay? Like, are you in prison?" Like, it was really funny.
Yeah.
Those were some great memories from the early day. But yeah, I think so. The next big turning point, which you did mention, was all the applications we got in based off of that first contract. And I remember we had for that first position, we had 83 applicants, and I went through every application. It was exhausting and tiring and hard to find the right person. And the last person that submitted, we had the application window open for 1 week, and it would close on Friday, close of business. And at like 4 p.m., right before the application closed, someone submitted their application, and I was like, do I really want to read another one? And I'm really glad I did, because that person ended up being our next co-founder, who was Mark. So he joined for a couple months on the contract, and then we brought him on to keep him, full time as a co-founder. So I think now would be a good time to bring Mark on and actually hear about his side of that whole experience and everything else.
Hello. Hi, everyone. So it's always so interesting for me to hear kind of that side of the story, because on my side of things, so I had graduated from school with a mechanical engineering degree about 4 years prior to that, and I was kind of phasing out of my previous job. I had been working in industries that I wasn't particularly interested in, and I really wanted to get into space, and kind of been interviewing around, had not much luck finding anything that was really in the area that I wanted. And I had kind of seen the Exo-Space posting and was considering it, but I was unsure because it was a contract position, and I really wanted full-time work. And I got home from this one awful interview where, it was super far away. I didn't like the people, just all across the board bad. And I was like, all right, I'm just going to submit an application and we'll see how it goes. And I'm so glad I did, because basically from that first phone interview, I just kind of instinctively knew that this was going to be the right fit. It was the right team. And yeah, I mean, it's just been kind of awesome since then.
Yeah, I feel like it worked out so well. It's really lucky that it worked out the way it did.
Yeah, and I got to hop on this really cool project that was basically what I had been searching for this whole time, like a really kind of intense and innovative and really, really complex engineering problem that's going to transport kind of the state of the space industry into like a whole new era. And we actually have the leader of that project on the broadcast today. We're going to bring him in just a little bit. His name is Dave Barnhart. But first, we're going to introduce you to the newest member of the Exo-Space team.
Hi.
Hey, Tate. We have Alex joining too.
I suppose so. There he is.
There we go.
Yeah. Hey guys. Hey Tate. I'm Alex. I'm an angel investor in Exo-Space. I'll tell you a little bit about myself, and then I'm really excited to introduce Tate Schaar to everyone. So I have a background in computer engineering. I'm a big computer nerd, lifelong computer nerd turned entrepreneur turned investor. And so as I said, I'm excited to introduce you to Tate today. I met Tate years ago when I was in college, and then later at one of my early engineering jobs at a company called Latronics about 15 years ago. So Tate, welcome. Can you give us a little bit of background on yourself, your work experiences, what you like to do, where you live, and anything else you think is interesting?
Sure. We talk about space, but I was a space baby. I was born in Florida during Apollo 11. I was fortunate enough to have a grandmother that actually managed an apartment complex in Cape Canaveral, just down the beach, literally right off the beach from the pads. So I grew up, seeing rockets go up and bumping into engineers from Canaveral and just soaked in it. So that kind of really always made me really big on technology, different things, whatever I can get my hands on. And probably my first grapple with technology, my father brought home a TRS-80 Model 3, the big, huge boat anchor computer to do basic programming to learn to teach his students. He was a algebra teacher at the local high school, and he never touched it. I spent the entire summer inside. I was 11 years old. I don't think I saw a ray of sunshine. I wrote code, I hacked, and basically it's been like that forever. And it went to hardware, and now I do all the things. Fast forward a long time later, and I was working for Latronics, and I met Alex, and we had a interesting connection, and we worked together for a while. And then Alex went his way. Eventually, I went my way. And we reconnected recently, and it was just like 5 minutes ago that we talked to each other. It was really great. And he's like, "Hey, by the way, I'm doing space stuff." And I'm like, "What? Cool." And the next thing, he said, "Hey, I got these guys. They kind of have a little need for some engineering. Maybe you should talk to them." And that's where we are today.
Awesome. So we had a great lunch. It was a lot of fun. We reconnected just like it, barely any time had passed, and started nerding out on space and hardware. So yeah, Exo-Space was the first group that came to my mind. So I'm really glad you were able to connect with them. So now, without giving away any trade secrets, can you talk about what you're doing at Exo and why you decided to join and all the interesting things that you're going to be working on?
Yeah, I'm trying to basically see how to efficiently put as much CPU power into space as possible. We have a lot of ideas. We have a lot of customer interest that we really are going to need to be flexible for, to have a lot of computing power, for it to be resilient, for it to be very flexible, have good access to the customers. We have a concept called Space Blade that we're going kind of Blade Runner, little Harrison Ford, that we're conceptualizing to basically be modular and fully expandable, very, very scalable to meet all of the needs of the future.
Awesome. So there's a product. It's probably going up later this year for the first time. What's your vision for the future technology? Like every engineer, once you start working on something, you realize there's things you want to change, tweak, improve. And of course, at the end of the day, we all have to be pragmatists and actually get the product out the door. So what's a little bit of your future vision for the technology path at Exo-Space?
Well, one of the issues with space, obviously is a reliance on rad hardened designs and things like that. So the actual capability of putting, a lot of computing power into space is really not feasible, especially with current technology. So to move that technology forward, to find ways to harness the tiny lithography, the really cutting edge megatops that we're seeing in some of these computing platforms, to get it up there, to get it efficient, to get it tolerant, to really harness that we have down here, that we see, every day with all the power we have up there. And it's no small feat, to make that really a feasible thing that we can fly.
Right. Well, that's awesome. I'm really excited that you're part of the team and helping push things forward. And so with that, I'm going to go ahead and pass it back to Mark to talk a little bit about some of the latest tech efforts and tell you more about Exo-Space.
Thanks so much, Alex and Tate. We're so glad to have you on the team. So like I had mentioned earlier, we kind of had a lifeline thrown to us by one of Jeremy and Marcel's mentors and the director of the Space Engineering Research Center. And he was actually starting his own company called Arkisys and had just gotten a contract with DIU to develop this novel space servicing platform. And so we're actually going to bring him in now to talk a little bit more about that.
Hey, Mark.
Hey,
it's
Dave,
great to see you guys.
here.
I really appreciate the opportunity, honestly. And I mean, to me, the coolest thing is the opportunity to sort of tout what you all have done so quickly. It's somewhat interesting because I also remember the time that Jeremy said, hey, yeah, we're still looking for somebody to help out. And we think we got this guy, but we're not quite sure, right? So, and then, you came to the first meeting and history was made after that. So really, really appreciate you being part of sort of help creating what we were starting with Arkisys, as well as, bringing Exo-Space in. So that's actually very cool. I actually love to give you a bit of background about Arkisys, and most especially to showcase how we've brought Exo-Space in specifically. So I'm not sure if either Jeremy or Melina, if you can pull up just one or two charts, that'd be great. There it is. So yeah, really quickly, again, my name is Dave. Really appreciate the opportunity. You guys can go check out our website. We got a whole bunch of stuff that's going on to talk about things that are happening. But one of our principal attributes, in all honesty, is to truly figure a way to accelerate innovation in space. And in all honesty, Exo-Space is at the edge of that innovation. See if we can go to the next chart. Be great. Sort of what is it that we're doing? Well, in order to sort of execute pushing innovation, we're really looking at taking that step sort of off planet, and we've got a big vision for that, and that really is to develop what we're calling ports, literally ports in space that can go to any potential altitude. They can grow of any size and shape, but most importantly, they can do services and support companies like Exo-Space to be able to grow, not just to have a platform to potentially test, but also to utilize what the company is doing actually in what the port is doing. So I'll show you that in a second. We can go to the next chart. I'll give you just a little bit of background. How are we doing that? Well, we have something called a port module. It's about 2 meters in size, about 1.5 meters big, and it's designed specifically as a building block to be able to connect to other port modules and therefore literally create platforms on orbit. Now, this is very exciting because this geometry, in all honesty, I can tip my hat to Mark, who was originally in the construct of figuring out what is the right geometry to create this kind of thing. So there's a lot of synergy here, because you just heard that there's aggregatable processors. Oh, wow, cool. We're doing aggregatable port modules. So that's all really good. The principle, the cool thing about the port and a port module, if you will, is that we can add new technologies to it and test new technologies. So ergo, Exo-Space having a really high performance processing system is directly in the sweet spot of what we can do, as well as our ability to innovate. And then the last chart, I think, shows we were lucky enough, actually next to the last chart, we've actually done live demos. And those first live demos utilized Exo-Space hardware. It was very cool because what Tate was talking about, that high performance processing can do so much in space. Well, we sort of put that to the test. We challenged Exo-Space. Could you take that? Could you apply a camera view coming in and give us an application for a rendezvous and proximity operation sensor? And then we'll tie that into our virtual demonstration and sort of prove that a spacecraft's coming in and Exo-Space is actually providing the data to the port and we're using it. So that was really cool. No kidding, Exo-Space algorithms actually demonstrated literal edge computing benefits, any real application that we use for our first live demonstration. The other thing we did, actually the last chart then, the other thing that's important about what we're doing at Arkisys from sort of a hosting standpoint, this is truly a port, which means visiting vessels comes to the port, robotic arms takes things off, puts things back on, and does things on the port. Well, we demonstrated that with the Exo-Space initial prototype payload. So that was really exciting. We actually did a full-scale demonstration utilizing a robotic arm. Our partner in this is Motive Space Systems, who was amazing in doing this. And we actually built a full-scale, one segment of the full-scale mock-up, and Exo-Space's hardware was there and actually ran through the entire sequence. So we're super excited about it. Really, really happy to have worked with Jeremy and Marcel to get them up, and then Mark coming on board, because I honestly believe what Exo-Space is doing is, no kidding, literally at the edge of innovation. So with that, shameless plug, I'll hand it back to Mark. So thanks very much.
Thank you so much, Dave. Yeah, I mean, I personally, and I think we as a team, see this collaboration as one of the major reasons that Exo-Space has been so successful, because like Dave was mentioning, it gave us an opportunity to kind of build out and actually test real data processing applications on our prototype device. And we actually have a video that we're going to show you from one of those live demos. Now I'll show a quick 30-second video recording of a live demo that we participated in earlier this month. This demo is meant to show how FeatherEdge supports space situational awareness for tracking approaching satellites. So in this video, you'll see the FeatherEdge device taking pictures 4 times every second and processing those images in real time. The box on the right is a FeatherEdge real-time feed, and on the left is just a secondary camera feed. You can see as the robotic arm moves the satellite, a red bounding box appears around the satellite and tracks it with our machine vision algorithm. The satellite is continuously tracked until it's in its resting position. All right, fun stuff. So that went by kind of quickly, and there's a little description, but I'll break it down a little bit more for everyone and kind of do a little more explaining of why this is so innovative. So the level of processing that is happening in this demonstration is incredibly computationally intensive. We're taking high resolution images and processing 4 of them every second. And so that in itself requires a lot of computational power. The preparation for this demo is also incredibly extensive, both on Exo-Space's part in terms of developing the model. We worked on that for about 2 to 3 months for each demo, and I believe we did 3 demos. And then we also worked to coordinate with all of the other members of the Arkisys team to kind of make sure that all of the systems were working in concert. We had some demos where we were feeding positioning data from our system into the control system of the simulated satellite, and causing adjustments to be made in the positioning of devices. And that's just a very brief overview of kind of the level of innovation that was going on in these demonstrations. And we would like to announce that we have recently renewed our partnership with Arkisys, and will be collaborating with them to fly their applique, which is the piece of technology that allows data transfer from the primary port system to any external payloads or vessels that are docked at the port. And so we're going to be hosting them on one of our 2023 missions, and I'm sure we'll have more updates about those efforts in the coming time. And now, after all of that kind of dense and sort of heavy technical information, let's take a step back, have a little fun, and we're going to do a little trivia session and giveaway. So we have a swag pack that we have on offer, and so the way that it's going to work is you all are going to leave your answers to the questions in the comment box. Let's see, where is it? Over here. Maybe not on that side. Not sure, but leave your comments of the right answer. The first person to get it gets a point. We have 5 questions. Person with the most points at the end will win the swag pack, and the Space Ventures team will be reaching out to you in your YouTube account for information on how you're going to receive that swag pack. So for a quick overview of what's going to be in that swag pack, we have an Exo-Space t-shirt. We have an embroidered Exo-Space hat. We have an Exo-Space pen. Very nice, heavyweight. We have an Exo-Space mug. Ooh, it's getting a little blurred out, with a picture of a satellite. We have an Exo-Space sticker. And that is it. All right, let's get into this trivia session. So for our first question, what does the acronym RPOD stand for? You got 15 seconds. Remember to drop your answer in the comments. All right, and there's our time for question 1. Question 2, when is Exo-Space's first launch into space? And we're looking for a month and a year. All right, and there's our time for question 2. Question 3, what global issue will Exo-Space's first launch address? Question 4, what dimensions define 1U? And we will accept either centimeters or millimeters. Remember to put your answers in the comment section. And question 5, last one. This is the challenge. How many successful orbital launches were there in 2021? All right, and here we have our answers. So for question 1, it was rendezvous and proximity operations and docking. Question 2 is October 2022. Question 3 is illegal, unreported, and unregulated, or IUU, or just illegal fishing. Question 4 is 10 centimeters by 10 centimeters by 10 centimeters. And question 5 is 135. see, do we have a name of a winner? All right, the results are being tabulated. All right, I'm being told that we will reach out in a message and we are going to move on to our next section.
Thank you, Mark. That was awesome. How many of you thought that the questions were easy? Myself, I didn't know at least 2 of those. So good luck to everybody that participated. And the Space Ventures team will be reaching out to you to contact you via YouTube so that you can get the prize. So yeah, Jose, me too. I'm very bad at trivia, unless it's Harry Potter trivia, which unfortunately didn't count here. So don't forget to drop your comments and questions for the founders. We also have our YouTube. Hello, Josh. Nice for joining. Thank you so much. We have our social media handles, so make sure to follow Space Ventures and also Exo-Space so that you can learn more about the projects that they're working on whenever they have new presentations or anything else. So we had some questions in the chat that I thought were really good, and I want to address one specifically. Jose asked, what are the benefits for Earth in your application? Like how it improves life on Earth? And I think this happens to be a question that a lot of people ask themselves when it comes to space. Like, how do we bring these technologies back to Earth and how do they impact us? So I will let Jeremy handle this. And as part of that, he's going to give us his overview for Exo-Space, what he sees the company looking like in 10 years, and how do he plans to improve humanity with it.
Great, thanks, Casey. And yeah, thanks, Jose, for the question. I will definitely address it as part of what I'm going to talk about next. So I wanted to take this time to talk about what I see the space industry looking like in the next 10 years and how I see Exo-Space fitting into that vision. So 10 years from now, I think the space economy is going to be very different than what it is today. First of all, the SpaceX Starship will be online and making regular trips to orbit. And honestly, it's hard to understate how much of a paradigm shift this will be for the space industry. You know, the cost to put hardware into low Earth orbit could drop to as little as $10 per kilogram. And for reference, today it costs like thousands of dollars per kilogram. So a cheaper ride to orbit just means more room for commercial activity. And it's not crazy to think that we'll see private inflatable habitats in low Earth orbit that bring 30,000 people a year into space for space tourism. We'll be building infrastructure for a permanent base on the moon. There will be people on Mars working side by side with rovers and drones for exploration. We'll have autonomous mining on asteroids and other planetary bodies. There will be companies manufacturing proteins and fiber optics to send them down for use on Earth. There will be satellites building megastructures on orbit for things like solar farms, where we can collect an unprecedented amount of solar energy in orbit and then send all of that renewable energy down to Earth. We'll have vertical farms in orbit to feed our growing populations, and we'll have vertical farms on the moon and Mars to feed astronauts that are living remotely. There will be mega constellations with thousands of satellites providing imagery and internet. And there will be reconfigurable satellites with modular parts. These satellites will have pluggable modular brains that we can scale for enhanced missions. Let's see, yeah, we'll no longer have to build every satellite on the ground. There will be satellite vending machines that can dock with and repair or make entirely new satellites on request. And similar to self-driving cars, it will be safer to have satellites dock autonomously with each other than to have humans in the loop like is currently done with docking maneuvers today. So I also think there's going to be a lot of technological advances with communications that are going to play an important role. And I think optical communications specifically will be commonplace, and they'll increase the satellite's available bandwidth by over 100 times what they currently are today. And this would allow, new interesting sensors that generate a lot more data but give, much more insightful information at the same time. So also in the next 10 years, there's going to be roughly 10,000 new satellites in orbit, and they're collectively going to be generating over 1 million times more data every single day. So the Lunar Gateway will be set up, and there will be a gas station and communication station at the Moon-Earth Lagrange point. It's sort of you can think of it almost as a midway point. That's like a region where satellites can stay with very little energy. But the data generated by all of these new operations that I've just mentioned will be passed through orbital data centers so as not to clog up Earth internet lines. These orbital data centers will be equipped with optical communication terminals and will be all connected over a mesh network in space. So they'll seamlessly integrate with Earth, but Earth will not act as the central processing point like it does today. There's just going to be way too much data generated from all these new activities to support an Earth-centric approach like we have today. So Exo-Space's goal is to provide the computing power for those orbital data centers. Full stop. That's what we are laser focused on as a company in the long term. The hardware computing market on Earth today is a $1 trillion market, and we're moving that market into space. So that's really the vision of what I see happening in the next 10 years and the role that I see Exo-Space playing. Our go-to-market strategy is a little bit different, and there's an important reason for this. You know, we're focusing specifically on machine vision for Earth observation applications. So Jose, to answer your question more specifically, you know, Earth observation satellites point their cameras at the Earth, and they monitor things like wildfires. They monitor oil spills, natural disasters, flood mapping. Those are the things that we're focusing on right now in order to build our technology towards this, 10-year plan. So let's see. I think some are coming in. Oh yeah. So I think I just answered that question. But now I can take a step down and talk about what a customer would like, the customer experience, what they would experience today when they sign a contract with us. So I'm going to pull up a presentation. Okay, great. All right, so this is a typical data flow for a customer working with us. So in step one, the customer will log into their online profile, and they will literally draw a box around their area of interest along with what they're looking for. So before I go any further, I do want to note, as a company, we understand the implications of this technology, and we're extremely conscious about the huge responsibility we have as a company to respect the privacy and safety of anyone who might be affected by, the missions that Exo-Space enables. So, why am I saying this? Well, because when we consider satellite technology, the cameras that are on orbit right now are powerful enough to read a license plate from orbit. So obviously, privacy and security are paramount when you have that sort of technology. So I just wanted to get that out of the way because I think it's an important thing to note as a company. So in this first step, in addition to providing this easy interface where a customer can choose their mission, location, and the parameters, our program also ensures that the chosen customer mission meets the ethical standards that we have set for the company before it moves on. But for the sake of example, let's say that our customer, working through this data flow, is interested in monitoring wildfires. So they would select their area of interest, and once everything checks out, the data flow moves to step two. So in step two, we have Exo-Space servers that are taking the area of interest and wildfire requirements from the customer and turning that information into a mission schedule that is forwarded to our ground station and then uplinked to our satellite network along with the relevant fire detection algorithm. So once it's uplinked, we have Exo-Space will have satellites on orbit that are continuously taking pictures of the Earth. So for our first launch in October of 2022, we'll have a roughly 5-meter resolution camera on board. And for future missions, we're also looking at cameras with much higher resolution, as well as ones with sensors that are outside the sort of optical red, green, blue spectrum. This includes synthetic aperture radar, but we're also looking at hyperspectral as well. So as our satellites continually capture images, we can move to step 4 to see what's happening under the hood. So in this step, this is where we run our patent pending software, which intelligently compares each customer's mission requirements with the captured photos to determine which algorithms need to be run for each image. So as an example, we might want to run algorithm A if the pictures were captured in a daytime setting, and algorithm B if the pictures were captured in a nighttime setting. So in the case of fire detection, we might see multiple images with forests represented on the left, but only one image with a forest fire, as you can see on the far left. So when a forest fire is detected, we move to step 5. So for step 5, we can see that the image that was identified to contain a forest fire is tagged as a priority item and will be sent down before all other raw data is downlinked at the next available ground station. So this ensures that the shortest delay, we have the shortest delay in getting the critical information to our customers. Additionally, if a customer enrolls in our ultra low latency program, which would be like for a premium price, then we'll send data, the analytics through a relay satellite and deliver that to the end user in 60 seconds or less. So once the information is downlinked, then we move to the last step, which is step 6. Analytics here are updated in the customer's profile where they can be accessed at any time. And this is the same customer profile that the customer used to create the mission parameters and the area of interest. And just to reiterate, this entire flow going from step 3, which is the uplink of the customer mission, to step 6, which is delivery of analytics, is less than 60 seconds, which really for the first time enables near real-time decision-making from space on a commercial scale. So that's basically what a typical customer experience would look like and the value proposition that we offer in this current market. So with that, if there aren't any questions, we can move on to the next section, which is a short video from one of our advisors, one of the artificial intelligence advisors to Exo-Space.
Jeremy, before we move to there, the audience is punishing us for giving them a trivia that was really hard, and they sent some questions our way. I'm just kidding. Please do drop your questions if you have more. So one that I want to address was, what is the most challenging aspect of developing the technology?
Yeah, that's a great question. I think the most challenging aspect is how do we fit the maximum amount of computing power into a device. So as Tate mentioned, that's what he's really focusing on. And that's a huge thing to tackle. There's the question of, do we use radiation hardened processors, which, obviously survive better in radiation environments, but don't have the performance that off the shelf processors have. So, the challenge that we have, this is actually our device right here. This will be launched on the first satellite in October. It's not very big, but to do, full scale image processing in this device, I think is the biggest technical challenge that we face.
Wow. Okay, one more question before we transition to the video. We have Kevin McDonald asking, given the likelihood of Amazon Web Services region in space as Project Kuiper is fielded, are you seeking to put edge interfering devices into the Kuiper constellation as the hardware vendor for the computer module for images inferencing missions? Sorry, I butchered that.
Yeah, sorry, I'm reading the rest of the question. Combined with AWS ground stations, this will allow for ordering of images. Yes. So yeah, we're very aware that there are a lot of companies working on edge computing solutions. What we're focused on as a company is, we're not committing to any one piece of hardware. Our IP and our value add is really the middleware layer that sits on top of the hardware. It's actually a hardware agnostic software layer. So what we do is, we source the latest and greatest components, the latest and greatest processors that fit customers' needs, and we'll implement that into our Space Blade and then put those in orbit, and then put our software on top of that. So we're actually talking with Amazon and Microsoft to see how we can best implement their cloud-based solutions onto our middleware layer. So yeah, that's sort of the strategy we're taking at this point.
Awesome. Thank you so much, Kevin, for your question. And if you have a follow-up, please feel free to drop it in the chat, just so that you guys know. Jeremy and the rest of the team will look back into the questions and answer them through their pitch page in the updates tab. So feel free to drop them. Even if we don't get to address them today, you'll get an answer sooner or later. So Jeremy, do you want to show us a cool video?
Yes, I think it's already queued up somewhere else, but let's show that one.
Hi, my name is Ritik Gupta, and I'm a graduate student researcher at the University of California, Berkeley, focused on the intersection of artificial intelligence and humanitarian assistance in disaster response. The goal of my work is simple. I want to find ways which makes first responders' lives easier. I want to make their lives less dangerous. I want to make sure that the aid that they're providing gets to people in a timely manner. And I just, overall want to reduce the risk to property and life that happens after natural disasters, wars, famines, and all sorts of other things that, impact humanity every so often. And a critical tool in kind of achieving all of this is satellite imagery. With satellite imagery, we're able to look at large areas of the world almost instantaneously. If there's someplace I want to look, I just, get a tasking from a commercial satellite imagery company, and I tell them to look in that area. And then within a day, I have an image sitting inside my inbox or within some sort of console that I can look at. And so satellite imagery is invaluable. The only shortcoming is especially in the areas of the world that I care about, there's not much imagery available because there is not much economic interest in making that imagery available. For example, almost no one is buying imagery over the open ocean. There's no reason to, right? There's minimal ships, you're only going to see blue water. What's the point? However, for science applications and for applications like humanitarian assistance and disaster response, it's critical to see those areas, even though they're not making anyone any money. And really the limiting factor is that even though I can go and pay a satellite imagery company to capture imagery, the imagery that they are capturing already is just not being downlinked because it's expensive. It takes time, it takes bandwidth, and frankly, that time could be used to just go take other taskings that people will pay them for. And so if there's a way, right, and there's this paradigm of edge computing, especially within orbit, that we can exploit that imagery in orbit, right? I can take my algorithm, let's say that detects dark vessels or that detects, oil spills, and I can deploy it on the satellite itself so that the resulting output of the model on top of that satellite imagery is much smaller than the imagery itself. Then I've automatically created a lot of economic value. People will buy the derivative product, even if they're not willing to buy the imagery, or if they're not willing to, pay extra to get this imagery, which may be taken away from other taskings. And so edge computing really is the future of space. When we talk about a hybrid space architecture, a lot of the conversation centers around edge computing, and rightly so, right? We're able to, reduce the amount of bandwidth being used. We're able to produce insights and share it along a large cluster, which can automatically take action on that data in orbit without ever touching the Earth. And so edge computing, especially edge computing in space, is going to be the next big market when it comes to the space economy. Exo-Space is a company I'm really excited about. They are not only building and working on some custom hardware, but they're also working on a simple to deploy, ease of use kind of mechanism to take any existing machine learning model and have it working in orbit on sort of any type of satellite imagery, whether it be EO, SAR, HSI. And so I'm really looking forward to what they're going to be able to do.
Thank you. So we had that video, which is great to hear because it's a third party kind of validating this problem and seeing the effects, going also back to Jose's question of why is this important? And ultimately that's the point. So we will do a little bit more questions. And in this one's a great way to introduce the next panel, which is Marcel. Marcel will be talking about some of the product details and some of the traction. But before we do that, I want to ask you, let me just find it right here. Could you give, what is the biggest or some of the biggest environmental challenges limiting computing in space?
Yeah, for sure. Thanks, Casey. Appreciate it. And that's a great question. One of the reasons why it's so difficult to just take sort of a processor that's terrestrial and bring it to space is a lot to do with sort of the radiation effects that you find up there. So without proper protection or shielding, these processors will essentially fail in space or what's called latching up. And this is the same for saving data as well. You'll get pixel changes and the data just won't store properly. Then there's also the problem of thermal. So the a lot of these devices go through a lot of different thermal cycles that you just wouldn't find on Earth when you're in a well-ventilated room. So these are some of the challenges that we're addressing, and it's been really exciting to be able to work on that. So with that, as Jeremy showed earlier, this is our sort of product that we are launching. This is the actual hardware device, and inside is a computing module integrated with our proprietary motherboard. So as you can tell, it's pretty small. It's what's known as a half U. If you remember from the trivia, 1 U is 10 centimeters by 10 by 10. And then you can see on the bottom here, is our 15-pin connector. And this is what allows us to easily integrate into sort of any satellite system with power and data lines. So the enclosure itself, so the metal around it, helps with two things. First, it's a barrier to protect the electronics against the effects of space radiation. And this is done by the high energy particles produced by the sun, and cosmic sources are actually absorbed in the material before it actually reaches the electronics. And then the second thing that the enclosure does is it acts as a large heat sink. So it actually dissipates the heat to the rest of the satellite that is produced by our high-powered processor. Since there's no air in space, we can't cool electronics with fans, which is what's typically done on Earth. Instead, we primarily use what's called conductive heat transfer. So I also want to show a video of our thermal analysis that we did. It's kind of a sped up version of it. I don't know if Casey has that up. Yeah, perfect. So here we have on the left is the inside of our enclosure and the thermal analysis that we performed. On the right, we have a typical orbit. So you'll be able to see that as it's in the sun, the processor is heated up and the heat is dissipated to the rest of the structure. But when it's in the eclipse, the whole system cools down. And then we actually have heaters on board that will detect when the processor is at too low temperature, and it'll heat it back up. But yeah, so that's sort of a little glimpse of our technology. So next I wanted to go into the traction section, which I'm really excited about. So I don't know if, I think now's the time to present the slides. Yeah. So yeah, I can't give away too many specific names as of yet when I talk about the traction, but I'm really excited to hint about it because it's a huge step forward for Exo-Space. So before I go into it, I first want to give a little background on the products we offer. It's been touched here and there. But for those who don't know, so on one side we have our services, and this is what Jeremy was talking about in his presentation. This is where we're trying to launch as many of our devices on Earth observation satellites to provide real-time insight on satellite imagery to our customers. And we also allow our customers to upload their own AI models onto our device, which is a really cool feature that we have. And then on the product side, we have our hardware, which I just presented. We have our software, which is sort of the middleware layer that Jeremy was talking about. And we actually have our AI models themselves. This is where we create our own detection algorithms for space applications. So yeah, I'll go to the next slide. Yeah, for traction, for our services side, we actually signed a contract with a company that will host their own AI models on board FeatherEdge this October. So we're really excited to have them on board, and we're going to be able to test out their models while we're testing our own models. So it's going to be great. And then we're also partnering with a software company that specifically creates their own AI models for use on Earth observation data, and we'll be able to actually use those models on our platform and service even more customers on our end. So these are really great partnerships, and it's going to propel us forward in terms of the services that we can provide on our platform. And then on the product side, and this is probably what I am most excited about, is that our technology has had a lot of interest for on-orbit servicing. We're actually finalizing contracts with 2 startups that will integrate our FeatherEdge device into their RPOD system. These companies are working on some really cool technology, and we're very excited to be part of that. And these won't just be sort of one-time contracts. If their technology is successful, then that means larger orders for Exo-Space. And we're also finalizing a contract with a company that is using our technology for orbital debris removal. So more satellites are being flown to space than ever before, and debris removal is going to be an important aspect of the space ecosystem. So we're really happy that our technology will be able to be used to safely deorbit satellites. And lastly, this is a big deal for us, is that we're finalizing a contract with a publicly traded aerospace company, which is huge. They will be using our technology to enable autonomous activity, satellite activity. And this is the future of satellites, where we're no longer relying on ground operators. And Exo-Space is in the perfect position to provide this capability to our customers. So yeah, we're really excited to share this with you. More details on these contracts will be coming soon. So if you are an investor, keep an eye out for emails from us.
Thank you, Marcel. That gives me an opening to shamelessly plug your social media. Make sure to follow Exo-Space. And it's pretty cool that they're working to mitigate space debris. I think that's an important issue in the space industry. A lot of us can agree. So the next segment is actually very interesting, because a lot of us during the pandemic grew hobbies or just decided to work out more or less, depending on your mental state. But it really impacted us a lot. And I want to emphasize how impressed I am about Exo-Space. They literally funded in January 2020, had a very bumpy ride through COVID, but they've done so much. And in addition to that, Jeremy managed to get a hobby that he is connecting with his company. And it's very impressive and very tasty. And so let's hear from Jeremy, his big reveal.
Thanks, Casey. There's so much build up to this. Yeah, so a lot of you probably don't know this about me, but I really like hot sauce, and I have multiple pepper plants growing in my apartment right now. Yes. I recently made what I think is actually an objectively pretty good fermented pineapple habanero hot sauce. So, okay, why am I telling you this? What have been all the Easter eggs that have been dropped in the emails this week? We're planning to release a limited edition set of hot sauce bottles for each time we launch a satellite into space. So this is the first bottle. This is what it looks like. The Exo-Space sticker is just a placeholder. So really, in the true spirit of crowdfunding, we're going to let you guys, our investors, name the hot sauce within reason. We won't accept Bodie McBoatface or anything like that. We'll still filter those names, but yeah, if you pick the name for our October mission, if you submit a name and we choose that, we'll send you the first bottle of hot sauce, and then we'll also be giving away 9 other limited edition bottles that will be chosen randomly from our list of crowdfunding investors. So if you've invested or you're going to invest before our campaign closes on April 28th, be sure to check the updates tab on our Space Ventures platform page and check your email to see if you won. We'll only be making 25 bottles for this first launch, and we'll see how the rest goes. So that's the big announcement. Yeah, we can pause here for questions if there are any last minute questions, and bring the team on.
Suggestions. Yeah, there's some suggestions being dropped already in the chat. My suggestion is put the face of the investor that wins the name in the bottle.
Oh, that's a good one, actually.
So it's some incentives guy. Drop some comments, like you said. Let's try to make it good names. But how awesome is that for each mission there's gonna be a batch? And I can't imagine Jeremy's apartment full of plants at this point. But that's awesome. Hopefully we'll get to taste some of that sauce pretty soon. With their launch coming in. So now I do have some questions. So let's bring some of the rest up because I want to put all of them in the spot. I'm just kidding. But we did say one of the best questions for last. So what was the best benefit for doing a crowdfund race? And will you do it again?
Yeah, I can take this one. So I think we had 2 really big benefits from doing a crowdfunding raise, and specifically doing our crowdfunding raise with Space Ventures. So the first, and probably the biggest, is that we were able to schedule our first launch and do all of the preparation that we needed to, which included manufacturing and testing a prototype device, manufacturing and testing our flight device, including putting it through environmental testing, which effectively qualifies it to actually be put up into space. And so that is all out of the way and paid for with the money that we have already raised in our campaign, which is just massive. And then the other benefit is that we've been connected with this really great network of space-focused investors and just people who are generally excited about space. And, you know, on other crowdfunding platforms, I think that's a lot harder to find. So I think we really owe a big debt to Space Ventures for sort of providing us with that network. And then in our next 6 to 18 months, we'll be preparing for that first launch, which is scheduled for October of this year. And then we will also be preparing for an additional 2 launches in 2023, and lots more exciting stuff that we'll be kind of getting ready to announce in the not so distant future.
Yeah, like I was looking through your traction part, and it's amazing how many things you have lined up. And as your company grows, I'm assuming your team will grow. And we got to meet some of the newest members here today. But so this leads to another question we had. What key hires would you need to make your next milestones?
Yeah, absolutely. So kind of 2 major positions that we're looking to hire on next. One is someone who is really focused on the software aspect of our solution. So this responsibility is kind of shared between Jeremy and Tate right now. And we're looking to kind of have someone who dedicates themselves solely to that, because Jeremy as CEO is really focused on sort of operations and logistics and overall vision. And Tate is really focused on the hardware side of things. And so having someone not only to build out the basic level of the platform, but also to serve sort of as an expert on the AI and machine vision side of things is going to be really key to our overall strategy. And then the other is something that we're kind of calling a chief revenue officer. So basically someone who is focused on developing all of our revenue generating strategies, and in particular our approach to defense contracting. And that's we see that as a major sort of revenue avenue for us, because there are so many defense applications for the technology that we're developing.
Yeah, I mean, I like that title, Chief Revenue Officer. It sounds like your job is to bring the money in, make it flow. That's responsibility description. That's awesome. So that leads to a good question. So what does your customer discovery look like these days? And I'm guessing this person that comes in is going to be driving a lot of the conversations as well.
Yeah, I can take that one, Mark. So yeah, for customer discovery, we have some we have contacts in Europe. We have contacts in the US who sort of work on a contractual basis with us, and they're just constantly generating leads for us and setting up interviews and meetings. So that's been really successful for us in the short term, and developing relationships with new companies. A lot of the traction we've talked about earlier has come from those introductions. So a big focus as well on the defense side, like Mark was talking about, is we've done the accelerators, we focused energy on those, but I think having a dedicated person for that is going to be a very important aspect of further revenue with the government. So yeah, I don't know, did I miss anything, Mark or guys?
Honestly, even just through our website, we've done, I would say, maybe 2 or 3 like legitimate contracts or finalizing contracts, just companies reaching out, asking about our products. So yeah, I think that's in turn of Space Ventures and us promoting ourselves on social media and stuff like that.
Yeah, I would say in the early days it was a lot of us cold reaching out to potential customers, and now it's kind of transitioning to a lot of potential customers coming to us, which is great to see. And I'd like to think that sort of our presence on Space Ventures and all of the publicity that we've gotten through that has quite a hand in that.
It shows that that people are starting to get the concept.
Yeah, I agree. And I think that once people start reaching out to you, you know that you're going in the right direction. So that's awesome. Before I hand you over the virtual mic to do your closing remarks, I would love for us to go over some of these suggestions because they're more on fire than I think the sauce is going to be. And the sauce is happening to be habanero. But we have ultra radiation, exo sauce.
Nice.
Let's see. Space spice, come for the view, stay for the sauce. That one's so. I love the tagline included in that one. Senior EXO. I like that.
These are great.
See. Let's see that. There was one more that I thought. Compute face.
Yeah, Alex, we're
Obligatory.
throwing that one out already. No, we're not.
All right. So you have several options. So keep. Oh, the quasar if it's really spicy.
Oh, that's a
So
good one.
you're gonna have a lot of options. So let's keep those scheduling those flights so that you can be lining up the suggestions.
Sounds great.
All right, guys. So with that, I'm gonna hand over the mic to you so that you can take a minute to tell this audience what you want to tell them and ask them to follow you and keep up with you.
Great. Yeah, thanks, Casey, and thanks for moderating this today. I wanted to thank everyone for tuning in today, and a seriously huge thank you to all of our investors for your support throughout this campaign. We can't overstate how amazing it's been to have you, and we're so lucky to have you on our team.
And yeah, if you have any additional questions, please remember to go to our campaign page and drop them in the discussion section. We will be checking that daily between now and the close of our raise.
Remember to visit our website. The raise closes on April 28th. Invest now when you can get in on the ground floor.
Yeah, we've accomplished so much with the crowdfunding investment so far, from booking our first launch to building our product, and this is only the beginning. So we want you, the space community, to come join us on this journey as we bring computing to space.
Thanks, everyone. Thanks
Thanks.
for joining. Bye.
Thank you so much, guys. With that, we're gonna start closing today. Thank you for joining us. Make sure to follow Exo-Space and Space Venture on social media. Thank you for your time. Drop more suggestions for sauce names because these guys are gonna keep launching and they're gonna need those names. Make sure to visit their race. And with that, I want to thank all the Space Ventures team that makes this live stream possible. Melina, Mariana, Nico, Chivika, our CEO, all our team commenting. Thank you so much for joining us today. And I hope you have a great day.